we are 4, no?
So right now we have 4 panelists. I have to hit the broadcast button. I'll hit the broadcast button in 1 minute. So we do have attendance. After broadcasting,
we'll start after 1 or 2 minutes.
Yeah, we'll wait for 1 minute after hitting the broadcast button so we can have attendance to join.
Okay.
Yes, sir. Okay, I'm hitting the broadcast button now. I think all settled. Let me hit the broadcast button and then we'll wait for 1 minute and then we'll start today's webinar.
Okay.
Professor, on your permission, should I, right? Okay.
Okay, yes.
Okay, now webinar is on the online and yes, sir. And I can see we already have a 30 participant join. Yep. To all the participants, good afternoon and very welcome to this webinar. We are going to start in shortly in almost about 1 minute. Soon, sir, I think we can start now. We have a 50 attendees already.
Okay,
joining.
fine. So good afternoon, everybody. On behalf of Techno India Engineering Institute of Technology, we'll welcome Professor Utku Kose, who is a renowned academician in the field of artificial intelligence. Just to brief about his illustrious career and sound academic performance and research records. He is associated to Süleyman Demirel University, Turkey, in the Department of Computer Science and Engineering as associate professor. He has received the BS degree from Gazi University, Turkey, and MS from Pocatep University, Turkey, and PhD from Selçuk University. He has been associated to IEEE activities both in international domain. He has published more than 150 research articles in journals of high repute, and he has some edited books, everything. And his research interests include artificial intelligence, machine ethics, optimization, chaos theory, e-learning, computer education, and computer science. Once again, Professor, welcome you, and we are really thankful to you for devoting time and agreeing for delivering this wonderful session. Thank you so much.
Thank you very much, dear Professor. Yes.
Yes, you can carry on. You can carry on, Professor. You can start.
Okay. I was just waiting if the other professors will be talking. Okay, thank you very much, dear Professor Chakravarti, for your kind invitation and introduction for me. I will now share my screen. I hope everybody will see it, see my presentation. I will share my presentation with Professor Chakravarti after the presentation. And dear Professor, you can send to everybody that presentation, or I can send to other professor also. My materials are all free to be shared with everyone. So everybody can be reading later in detail my presentations. Yes. I think you are all seeing my screen. As you can see, my presentation title is New Concepts of AI and the Future. I will talk about some of new concepts of AI and also consider some future perspectives by considering new concepts of AI. Let's start. I will just start my presentation also. Yes. I can take our video views to the right side. Yes. Professor Chakravarti has introduced me already. As you can see, I'm associated with the Department of Computer Engineering of Süleyman Demirel University, located in Sparta, the city of Sparta in Turkey. And that's my the content of presentation. As you can see, we will just make a brief introduction to the AI at first, and after that I will talk about some subfields of AI and some techniques that we may heard already about them. But of course, when we talk about the future of AI, we should be talking about the current state of AI systems. So I will talk about them, about the present problems and present state of the field of AI. And after that, I will talk about near and far future of artificial intelligence by considering new concepts. And after that, I will talk about also some open problems, give some suggestions, and after that, I will take questions by all listeners. Yes, Professor has already introduced me, but as you can see, there are my also some academic profiles. If you desire, you can visit them. Also, you are all free to visit my personal website to learn more about my research interests and more detailed information regarding my publications. You can just keep tracking my profiles and also personal website. The rest of the information has been given by kindly by the professor. So thanks again for his invitation and as well as the kind introduction for me. I'm currently an associate professor at the Department of Computer Engineering of Süleyman Demirel University. It's located in Sparta city and Turkey. And before starting, I will of course talk about the Sparta and my hometown Afyon, which is near to Sparta. As you can see, there is the border, the common border between the both of these cities. Sparta is famous with its roses, so because of that, we already have a rose sign over the logo of the university. And we are also, as the city of Sparta, we are also located in a region of lakes. There are lots of lakes, big and small sizes. So you can enjoy the view of such lakes, the roses, and also especially green areas because of some rain and some different weather conditions as different from other cities surrounding the Sparta. So you are all welcome to and enjoy the city of Sparta. And also my hometown is Afyonkarahisar. It's famous with especially the start of the independence war of the Republic of Turkey. So there are lots of signs regarding that in that city. And also you can see there is a big rocky castle in the middle of the city. So you are all welcome to see lots of historical and many different things associated with the independence war of the Turkey by visiting Afyonkarahisar. You are all free to visit both cities to see some beauties of our country. Of course, there are other cities. You may already know about Istanbul. Everybody knows Istanbul in Turkey. And maybe you may already hear about Antalya, for example. It's located and near to the Sparta, the city of Sparta, and located near to the sea. Because of the seaside, there are lots of tourists coming in summer times to Antalya. So you can also visit Izmir or other cities like Mersin or Trabzon on the north side to see some more green areas. So you are all free and welcome to visit different cities of Turkey, not only Istanbul, but there are also lots of different cities. And especially if you come to Sparta and Afyon, just let me know so I can take you to see take you to some places, known places of Turkey to see beauty of Turkey. Yes, when we talk about my university, you can see the logo on the left side. There is the rose. Sparta, the city of Sparta has lots of things regarding roses. So it's sometimes you feel bored about seeing lots of roses in the city, and there are lots of shops selling some products regarding roses. But it's famous, especially for its roses and also lavenders, for example. So it's an enjoyable city with lots of beautiful views of roses and lavenders. So because of that logo of there's a logo of the vectorial logo of rose is located on the logo of Süleyman Demirel University. Süleyman Demirel University is a public university, is located in Turkey and established in 1992. As you can see, there is the Süleyman Demirel, the name of a famous former president, one of the presidents of the Republic of Turkey. So, and he was also born in Sparta. So that explains why we have his name in the name of the university. That's because we call the university as the Süleyman Demirel University. And we have around 70,000 students for now. And with that number, we are known as a large academic institution in Turkey. And the STU is known for its programs in agricultural research, medicine, engineering, and business science. And when we talk about our department, we have three professors. Our department has three professors, two associate professors, and I'm one of them, as you know. And we also have 8 assistant professors with 2 research assistants working in 3 different areas of computer science, computer software, and computer hardware. We host lots of students with Bachelor of Science, Master of Science, and PhD degrees. And we especially have lots of the international students coming from different regions of the world. So you are all again welcome to visit our department and our university. And our department is and will be always free and open for international students coming from different areas of the world. And as you know from me, maybe we are, as the department, we have already focused in research regarding artificial intelligence, but not only artificial intelligence, but we also work in, for example, robotic systems and also optimization problems and also wireless networks. We all have different domains of research, and one of the most important research areas, as you know, for currently, the artificial intelligence is among our top priorities in terms of research. Yes, let's start to talking about to be talking about AI. What is AI and what is its the origin in terms of especially research interests? As you know, the field of artificial intelligence is very famous because it's already enrolled in all fields of the modern life. And we can say that currently, as you know, the deep learning or machine learning are very famous with their very effective results in solving real-world problems by running especially trained systems and trained intelligence systems. So that explains why we are all focused on that technology of AI, and why every field is enrolled in research regarding artificial intelligence and its subfields. When we try to explain that, we may just give a reference to the father of that concept, Professor John McCarthy. As you already know about, for example, Professor Alan Turing, who has invited some electromechanical devices to solve the Germans' Enigma system during the Second World War. But that was just the start of the rising some electromechanical systems which can be effective to run their own solution scopes by not requiring direct control of humans. But there is also very deep historical state of the field of artificial intelligence, because it's already supported with different technologies like data processing, data science, or electronics, and also other technologies like computer and software technologies. So we can say that it's a very big and multidisciplinary science rising over different supportive technologies. But when we look at to Professor John McCarthy, we can just reach to a very brief explanation that defining the field of AI as the science and engineering of making intelligent machines. When we think about science and engineering, we just come and reach to both theoretical and applied sides of different scientific fields. When we talk about, for example, physics, we can say that there is the applied side of physics, and there is also the theoretical side of physics. And as you know, the professor, for example, Stephen Hawking was and is known as one of the most important and famous theoretical physics in the world. So the field of AI is something like that. We should just talk about both theoretical and applied side of that technology, that field. So by moving from that, the Professor McCarthy just says that it's the science and engineering of making intelligent machines. John McCarthy has just expressed the concept of AI in the conference at Dartmouth, USA. And after that, we just started, as the humankind, we just started to use the concept of AI for explaining the systems or machines in terms of both software and hardware side, which can be able to solve real-world problems by just running some training or learning steps regarding past known samples of the target problems. So that brings us a very wide multidisciplinary science as well as the science of the future, because the field of AI is very successfully applied in different fields, as you know. But on the background, there is the mathematical and logical side making that possible, that all successful results possible for the humankind. And we can say that as like the computer programs are just somehow an interface between humans and the computer systems, the field of artificial intelligence or the tools derived or developed by the field of AI are just interfaces between human and the machine. By just thinking about robotic systems, we can say that the field or the components of the AI systems, maybe software components, are just interface making humankind to be controlling or to be directing the robotic system to make its own problem solution or problem solving steps or problem solving actions by not requiring any other additional operations by the humans, for example. So that brings us that the field of AI is a combination of mathematical and logical algorithms. It's a multidisciplinary science. It's the science of the future. It's an interface between human and the machine. And we can also say that it's just a way for improving effectiveness and efficiency, so that we can solve real-world problems in all fields after especially the start of the 21st century, because we were just able to say that the field of AI is just successful in many fields, but not all fields till maybe end of 20th century. But after rise of different technologies like software technologies or other technologies surrounding the field of AI, we can now directly say that the field of AI is associated with all fields, and it provides effective results for all fields, including even music, even literature, even other natural science maybe, and other fields of social science like education. So that's why we say that the field of AI is the science of the future. And we can say that there is the technology side, which is used for developing intelligent solutions thanks to the field of AI. And that is done by somehow providing a simulation of humans, animals, and nature. By starting from inspiring from the brain mechanism of the humankind, the field of AI, after a while, the field of AI just started to be inspiring from animals, collaborative actions done by animals, and also it has just been performing some or providing some intelligent algorithmic structures inspiring from some natural dynamics, for example, like flow of the rivers or change of the seasons or the other the occurrences in the nature that may be explained with physics, for example. And just by combining all of these things, we can say that the field of AI is just somehow a simulation of humans, animals, and the nature in order to solve real-world problems. But as you know, after especially maybe the start of the 21st century, everybody has just started to be discussing about the future of AI. Everybody thinks that the AI will be taking over our jobs, will be being spread over all fields by eliminating humans and making us maybe lazy in terms of our tasks along the real world. So everybody asks that if it's an utopia or dystopia, and also everybody asks that if it's a technological risk or threat for the humankind. And of course, we don't know that exactly very well yet, because the field of AI is just a product by the humankind. So that explains that we are just the main the responsible component for defining the future of the AI, so making it a technological risk or an helpful tool for the humankind for the future. And so there are lots of discussions regarding if it will be a cause of extinction, and it's maybe a science without human, but we cannot say that because it's already a product by the humankind. And as I've said before, it's not a science evolving by its own efforts, because the field of AI is supported by many different technological fields like electronics or other computer technologies or other technologies. So because of the rapid development in such different fields, the field of AI is gaining more and more momentum day by day. So the future of AI seems to be very open wide for the humankind, for the world, maybe for the universe. And we cannot for now say that it's a stable technology, because it's all surrounded by different supportive technologies. And when we think about some subfields, we can already think about some fields like, for example, machine learning. Machine learning is exactly the subfield of the algorithms which are able to learn from past known samples to provide effective solutions for the real world problems. And for currently, we can say that there is the deep learning, and deep learning is just a different variation of the machine learning by dealing with especially big and complex data. Big data is already having some features like having complex data, rapidly gained or obtained data, and data including especially unstructured components, for example. And the amount of the data is big, as we call it as the big data. And after a while, the machine learning was not able to provide very successful results in terms of big data, especially. So currently we use a new form of machine learning, which is called as the deep learning, to provide some learning algorithms which are successful against for even big data. And by taking a look at to that picture in the current slide, we can say that the field of artificial intelligence is just divided into two main groups, which we can say that the algorithms with learning capabilities, which we are calling as machine learning, and the other algorithms which do not require any learning phases, maybe some mathematical modeling or some rule-based definitions by not requiring direct learning steps. but that doesn't mean that all of these not learning algorithms are not very successful against real world problems. That's just the way of the problem solving. When we encounter with problems requiring some learning phases, like the humankind to learn more about the problem and having more ideas about how to make synthesis regarding feature solutions, for example. And in some problems, we do not have been requiring many learning steps. By just looking at the problem structure, we just run some already known problem solutions maybe. So that explains that the artificial intelligence has the learning algorithms and not learning algorithms with both two main sides. And when we come out of the learning algorithms, machine learning algorithms, we just reach to optimization, for example. All of these are just full of algorithms inspired from the nature, from animals, from other natural dynamics, as I've expressed in the previous slide. And all of these require some maybe continuous or combinatorial optimization problem definitions in order to run some loops, some iterations to provide some near solutions, near values, or optimal solutions for your target problem. And all of these algorithms do not require learning steps to be adapted to the target problem like it is done in machine learning. So that's another way of artificial intelligence. And we know about cybernetics. Cybernetics includes some robotics and medical operations to provide people or living organisms to make their some capabilities to be improved and or add some additional capabilities or abilities out of default abilities we have. For example, by just running cybernetics, you just develop some electromechanical devices or electronic devices to support a man without arms, for example, by just using some robotic arms, by just thinking with his brain, for example, or by just using additional arms, you just became something like a spider, like a Spider-Man, and just you have two or more additional arms to carry on some difficult tasks like carrying some heavy things, for example. So that cybernetics or that robotic system just adds some additional capabilities to your default capabilities. Or you may just use some spatial lenses to have some night vision as out of the default capabilities of the humankind. That's the way of the cybernetics. And cybernetics may be using both machine learning or optimization or other techniques to run that solutions. So that gives us another subfield under the artificial intelligence. And also we already have some associated technologies, some smart tools like Internet of Things, Internet of medical or health things, wearables, or other components like wireless smart sensors or other smart tools we can call it as building some smart campus, smart home, smart environments maybe. So these are all associated technologies coming from the roots of the artificial intelligence, but associated with also electronics maybe and communication technologies. And all of these are current state of the field of AI. And when we come to the bigger view for the supportive or associated technologies surrounding AI, we can just reach to a schema like that, for example. We already can derive some alternative views, of course, but I just try to provide somehow a schema explaining some relations among different fields. As you can see, there is the AI with the yellow circle, and as you can see, machine learning is one of the subfields of the field of AI. and deep learning is the subfield of machine learning, and as the sub and subfield of the main field of artificial intelligence. As you can see, there is the data mining. There are some algorithms which we examine in both AI and data mining sites, but with some different algorithms or techniques. The field of data mining and AI are just separated into two different waves. Exactly, or actually, we can say that the data mining includes some algorithms or techniques which are able to run some operations over data, for example. But the AI, the concept of AI is just more a concept of more a popular cultural term, which is used for defining the way of the providing solutions by just running some artificial components, like inspiring from the natural intelligence for solving problems. So they have just common things, but also have some different things in terms of their used algorithms or solution mechanisms. For example, the association rules and a priori algorithm is just maybe examined under the data mining and not directly under the artificial intelligence because of its roots in terms of algorithmic style. And when we come to other supportive technologies, you can see the robotics, the cybernetics, you can see the electronics, which is very important in terms of computer communication technologies and the AI. And without having electronical components, we would not having such technological components, including mobile phones, other things, televisions, or other many other technological devices we are using widely to solve real world problems. So electronics is especially important in terms of AI. When we talk about robotics and maybe IoT, for example, or communication technology oriented results, so it should be located here by when we talk about the field of AI. And as you can see, there is the communication technology. It's here because we talk about the IoT, we talk about smart technologies or communication solutions. So we can say that it's another supportive technology for the field of AI. And also, as like we human, as the humankind, we just study some books or learn something from different materials, or just going to school or going to university to have some lectures. We just try to eliminate some things or learn something more about the target problem, so we can just save time and be knowing more about the target problem. So the data processing is just performing some mechanisms like that to make some data to be more understandable, but by the field of AI, by the AI tools. So image processing or signal processing are very important supportive technologies and algorithmic methods to support the field of AI. For example, when you just make medical diagnosis, you just run some image processing to make your medical data, medical image data, to be more understandable, to be more giving more details to the artificial intelligence system, so it can be running more effective results in a shorter time. Artificial intelligence is not responsible for always for example, filtering data or making some pre-operations to make your data more understandable. It's just the responsible of the data science or the data processing, which includes methods and techniques under that field. Yes, when we come to machine and deep learning, we just need some training phases, testing phases, and application phases. And that just raises some problems. For example, how to model the target problem to make the or to make having the exact successful results to be obtained at the final step successfully. If you model your problem incorrectly, your machine or deep learning system will be probably giving you incorrect results for the future problem states, for example. And because of that, you just try to give an exact and true model of the problem. You just use some past noun samples or just some reinforcement techniques to make some learning by experiences steps to make your system, machine or deep learning system to be trained well enough. But again, you just train your system to see if it has trained well enough according to past noun samples or some experiences just we run for making it to be trained. And after passing the test, it's just like us, because we go to schools, we take some lessons or lectures at the university, and after that we just try to pass some tests, examinations to become graduated or having jobs, for example. It's just very similar in terms of machine and deep learning. So by performing testing, you just try to see if your system has been successfully trained with the past noun samples. And after passing the tests, which include some samples which have not been known during the training phase by the system, but known by us, maybe by the human side who knows about all past samples or known experienced states. And after passing the testing state, we just take our system, machine or deep learning based system, to be run along the real world applications. And all of these rises again some issues like training issue, how many times we should train our system, and which techniques or parameters we should be using, because there are lots of hundreds of different techniques to be having learning capabilities as included under the field of machine and deep learning. So all of these are important problems. For example, neural networks is very important machine learning technique. It's just inspires from the learning mechanism of run by our brains. It's just try to manipulate some noun samples by just optimizing some weights, so that it's just try to predict or give some effective solutions for unknown future samples, future states. So that's very similar to our thinking style, because when we talk or study more about something, we just save some information in our brains because of some electrical states among the associated natural neurons. And as similar to that, the artificial neural networks just use some weights and some input and output data to make that happen, to be stored some information thanks to some optimized or adjusted weight values. So that's a very important machine learning technique. And when we come to deep learning, we just have more advanced forms of neural networks, and they do not require generally feature extraction, which is done by data processing methods, for example, because they have some different layers, different artificial neurons, which have some certain mathematical and logical operations to make some feature extraction and problem solution steps by not requiring additional use of different methods. But you again can again use some data processing steps before deep learning to improve more and more about the success about the outputs. So deep learning is, as I've said before, is just the current state of the deep machine learning. And I don't know if the future will be giving different algorithms or techniques out of the form of the neural networks, and probably that will be real in the future. But now, for now, we just have some advanced forms of neural networks coming out of the machine learning, and we call all of the group of all of these advanced neural networks as the deep learning, which is able to deal with more advanced mode of data, which includes big amounts, complex structure, unstructured style, because of that complex way, and the fast flow of the data gathering, and also many other things, the data coming from different sources. So they have not very common characteristics, for example. And because the machine learning was not very successful, it was evolved into deep learning, and deep learning is the current state of the learning algorithms of the field of artificial intelligence. And also, we don't just have the machine learning techniques. For example, we also have fuzzy logic, which is able to provide some logical problem solutions coming from rule-based structure, which is not requiring machine learning steps, for example. And it was inspired from the theory of fuzzy theory by the Professor Zadeh, a mathematician and computer scientist from Azerbaijan. And it just says that the logic is not the real logic. The logic in the real life is not associated with just two groups. We cannot say that something is just true or false or black or white. We can just say that the different values may be associated with more than only one group. So that brings us to the fuzzy logic. Fuzzy logic is another important technique for the current state of the artificial intelligence. And also, as another techniques groups as out of the machine learning, we have optimization algorithms, intelligent optimization algorithms, like particle swarm optimization, genetic algorithms, Kuko search, artificial bee colony, or other algorithms coming from many animals and bugs or insects from the real world. And genetic algorithms is among one of the most known that's intelligent optimization algorithms, and is just focuses on the theory of evolution, and just runs some collaborative solutions to derive some unknown variables, to derive some values regarding some variables of the target mathematical model of the target problem. And by just running some genetic or evolutionary theory based mechanisms, it just uses successful components, successful results to be evolved into more successful results, more optimum results in a loop or in iterations, to make everything faster and more accurate in terms of solving optimization problems. Yes, when we come to present problems, by the way, I have explained that neural networks or genetic algorithms or fuzzy logic because these techniques were all the starting point for me when I tried to learn or tried to start to the field of artificial intelligence during my Bachelor of Science, for example. So I have explained briefly about them. So I will give some suggestions like that, running among them first to learn something about artificial intelligence, and then improving your knowledge by locating some additional things, additional knowledge over them by learning more things about the current state or current techniques of the artificial intelligence. Yes, I will talk about them under the suggestions, under the slides regarding suggestions. And when we come to present problems, we can say that there is the prediction side provided by artificial intelligence. There is the pattern recognition, which includes deriving some hidden patterns out of the known data, because as the humankind, we are not able to derive some hidden patterns to learn about the target problems. So pattern recognition is another side of the AI. And we already use optimization because the life is actually optimization with full of algorithmic steps. We run very fast to optimize something during our daily life, for example. And also, especially machine learning is exactly somehow an optimization. So we can just build up some hybrid systems by training machine learning techniques by running some optimization algorithms, for example. So that's another subject, another topic to be discussed, but it's another additional information that you may know or you may consider while studying artificial intelligence. And also there is the adaptive control, as you know, by the, for example, fuzzy logic or other techniques to make especially electronical devices to be controlled adaptively in time without needing or requiring instant control by humans, for example. And also there is the discovery side, and at the time of the COVID-19, for example, there is a very urgent need for information discovery, drug discovery, which includes building some vaccines against or for COVID-19, and that's done by the problem solution side as the information discovery provided by the field of AI, by just running different techniques like maybe neural networks or other techniques or hybrid systems, by just combining traditional methods and AI methods to run through pattern recognition, prediction, discovery, control, or optimization. All of these present problems are just some known problem scopes of the current AI. And when we run a typical AI system, we may just require some feature extraction, as I have explained before, explained during explanation regarding to deep learning, or just like done by deep learning, you may just not needing to feature extraction to make data more understandable for the your intelligence system. But in both states, you just make some data to be ready for your system, and after training or testing or just using your system directly to the application, you just run or reach to the run of your or employment of your intelligence system, whether it's machine learning or other things. You just run something like that to make everything to be learned or to be successfully solved by artificial intelligence based tools. And for reaching to the solution, you may already using your artificial intelligence based solution in directly to be having effective solution at the end, or you may be using or deriving as a way of indirect use for reaching to effective solutions in the end. So that's a general view of the how to run your intelligence systems, whether they are hybrid or not, for target problems from the real world. Yes, and when we come to the future of AI, we just reach to some new concepts, or some new concepts are very important to talk about present state and the future of AI. For example, there are lots of discussions, as I've said before, at the start of my presentation. And when we talk about more details of about the future of AI, we may just talk about the more amount or more use of or more big amount of AI-based systems taking over our jobs or taking place in daily life, as like it's imagined in science fiction movies, maybe. So we can talk about assistants. For now, there are some software-based assistants like Siri in iPhone, for example, but the robotic assistants will be probably possible in the future. So that's just a time manner, for example. And we can say that there will be also unmanned machines in the future, in the near future. We already have some, for example, some self-driving cars and unmanned vehicles or tools, technological tools, electronical device used by many companies around the world. And the future will be probably having more and more such things to make or trying to make the real world easier for us. But we will see, of course, if they such practical solutions will be good or not for us, because as the humankind, as the humans, we need physical movements, physical actions, and we need social interactions without having some middlewares like social media, for example, or other the electronical components like internet or communication technologies. But we will see, of course. And we will probably see new jobs or expertises in terms of AI or other known jobs with having some common routines to make something happen during daily life. And because of that, we will probably see change of current jobs. For example, just think about data science. Data science is just a different way of the statistics, and it runs just more different computational components or techniques to derive more effective solutions except from statistics. But the main roots of the data science is just associated with statistics. It's just something like a bridge between the statistics and the AI maybe, or new innovative technologies we know in current state. And when we think about jobs, if your job has some routines in dealing with the real world tasks, we may just think that such jobs will be most likely to be computerized because you run some routines always, and the computer-based systems and the AI will be very effective about making them happen in a shorter time and by not feeling bored or tired, for example. But if your job includes more humans, for example, as the target problem, for example, just think about therapists or psychologists, because they are working exactly on humans, and because the human kind has a complex nature in itself, such jobs will be least likely to be computerized in the future. I'm just passing them. You may just take a look at to them. For example, you may already think about the financial jobs, and not all of the jobs associated with finance or economical jobs will be all taken over by the AI, but some of them will be easily taken over by AI. But your job or sub job under the financial field has some problems regarding the human. If the job hits the human as the target problem, they will be probably least likely to be computerized by or taken over by the field of AI. That's similar to different fields, different jobs. For example, we already know about artificial intelligence-based lawyers, but it's not very easily like taking over the job of, for example, air trading or retail salespersons, for example, or security guards, or maybe secretaries like personal assistants, for example. But there are some different changes of rates of having your job to be taken over by AI. But when we think about how that will be possible, because as you have already seen that we have just some different problem scopes to make run of artificial intelligence base to make all of these things happen, or to make, for example, medical diagnosis or predictions real in terms of current problems. But when we talk about more detailed problems requiring use of IQ or your intelligence to be synthesizing or to be building some solution steps before running the exact solution, we should just think about more advanced forms of AI. So by thinking about that, scientists and academicians have already introduced some new concepts of AI. These new concepts of AI are especially will be effective for near and for future of the AI. By thinking about the new concepts, we just call the current state of the AI as the artificial narrow intelligence, which explains that it allows AI to execute specific focused tasks without ability to self-expand functionality, for example. And that allows us to be having enhanced or improved jobs at hand, and it's just outperform humans in specific repetitive functions like driving or medical diagnosis or financial advice or other things, as I've said before in the previous slide, in terms of different jobs. But when we talk about more detailed solution developing side or running some more complex mechanisms to derive some solution steps, and then after deriving solution steps, running them as like the artificial narrow intelligence, we just reach to artificial general intelligence, which is another new concept of AI. It's not real for now, but about 2040, it seems to be raised or thought to be raised by scientists. It allows performing broad tasks, reason and improve capabilities to comparable to humans, as you can see explained here. And as compared with the humans, it can AGI, I will call like that. AGI will be competing with humans across all endeavors, such as earning university degrees, for example, or convincing humans that it is human, for example, like passing the Turing test. There are already some systems passed Turing test, but Turing test should be reshaped as the worldwide scientists are already discussing about that. So the feature of the AI will be associated with the AGI, artificial general intelligence, will be dealing with the problem that if it will be having a successful problem solution sites to be deriving some solution steps and then running its own solution steps to solve the target problem. It's just like building something. You will just be giving your intelligence system in the future maybe a guide, for example, has written some steps over the paper, and after reading the steps and analyzing how to build something, maybe chair or table, maybe, or just building a house, maybe, after reading and making some sentences about how to solve that problem, the same system will be able to build up your house or chair or table. That's the exact mechanism of artificial general intelligence. For now, in terms of artificial narrow intelligence, we just give some known past samples or some known state of the problems. So we just make some jobs or responsibilities of intelligence systems to be easier for now. But artificial general intelligence will be responsible to be deriving the solution steps by its own efforts. And the more that the new concept of AI or the new maybe form of AI is evolved, it will be probably reaching to artificial super intelligence, which was introduced by Professor Nick Bostrom from University of Oxford. It will be probably seen soon after AGI, and it will be having the possibility of having the humanity at risk, for example, as expressed by Professor Bostrom. It will be demonstrating, providing or demonstrating intelligence beyond human capabilities. It will be able to build up its own artificial intelligence-based systems like Terminator does in that now movies, and it will be outperforming humans, helping to achieve social objectives or threatening human race, for example. So that's is another concept which is also widely discussed because of its unknown or blurred way of future, way of problem solution for the future. So many scientists think that we should be having some artificial intelligence-based or safety-based solutions to be able to give some technological components which will be, for example, interrupting dangerous intelligence systems in the future. There are already some papers, some research works, as if you search about artificial intelligence safety or ethical artificial intelligence over the web, you will be probably reaching some different important papers which is rising over, especially advanced mathematics and cryptography to build up some safe intelligence systems for the future. And we also have another concept of ambient intelligence. Actually, the ambient intelligence is not a very new concept, but it's a concept which is rising more and more popularity thanks to IoT, especially IoT. Just think about a feature which you don't know, or it is not necessary for you to know about that there are some intelligent components surrounding you to solve your daily life problems, but you are already supported by some components like sensors and cleaning robots or medication controls or other things to make some environments, some ambient to be running or to be supported by some artificial intelligence-based solutions to make your life more practical, more safe, and to be or making you to be being well-being or having a better level of well-being or keeping your health state at a stable level, for example. So that's something like an IoT, but a more advanced form of IoT, which includes that you just use everything as a common thing, but everything has some artificial intelligence on the background, which means ambient intelligence. That's the picture you can see. It's exactly the explanation all of that ambient intelligence. And such systems will be probably not requiring too much interaction by you, and they will be acting or making decisions in their own efforts. So that's the ambient intelligence. Because as the IoT, we already have some needs to control by humans, but ambient intelligence is somehow an evolved way of IoT, maybe. We can just call like that. As you can see, there is the artificial general intelligence. We just reached to moving from the weak or narrow AI to the strong AI, which means the artificial general intelligence. I'm just passing that because I have explained something about that. The artificial general intelligence will be able to understand abstract concepts, explain about why different results are obtained. I will explain that in next slide under the explainable AI, another new concept. And for example, the artificial general intelligence will be creative like children, will be telling right from wrong or having emotions. We will see. We will see because the emotions is another important thing, or maybe ethics are very important things, because as the humankind we don't already have enough information about them, how to model them, how to make them understandable. But we will see if it will be possible to understand or to tell or explain to artificial intelligence what is exactly emotion or ethics, for example. We will see. And as another new concept of AI, there is the explainable artificial intelligence, which means the artificial intelligence having capabilities to explain why it has reached some decisions at the end. For example, when we think about current intelligence systems, we cannot ask to systems, why did you do that? Why not something else? Or when you do you succeed? Or when you do you fail? So we should be having some or trust level to the current intelligence systems, and we just make some or take some risks for the current intelligence systems that they are giving us true solutions. But we cannot ask them, how did you do that? How do you reach to that? Because we can ask, for example, to a doctor, how did you reach to that decision, to that diagnosis, and so he or she can explain all of the process or thinking style he or she just did, for example. But when we come to explainable artificial intelligence, which we can say XAI, we just use additional components like explainable model to make the system to be giving us accurate answers when we ask it questions about the solution process or the solutions at the end. It says that how it has reached to the related solution, or which kinds of solving phases it has just run to make the final decision real, for example. That's exactly the form of the new concept of explainable AI. Yes, when we talk about by moving from that new concepts and more focusing about the future of AI, we can say that there will be new AI techniques under that explainable AI or AGI or ASI, maybe super intelligence. I mean, there will be new AI techniques because the field of AI is full of research efforts regarding rising new techniques, building up new systems. And also for currently, there are many research works regarding hybrid or hybrid models to improve some obtained results for certain problems. So future will be probably having more efforts regarding building hybrid models again. And also choosing true parameter values, data sites, machine learning details, issues regarding how to train your intelligence system correctly in terms of machine and deep learning or AGI or XAI maybe, are all open problems for currently and for the future. They will be always alive because the field of AI will be always needing such problems to be having its own momentum in terms of scientific advancements. And also solving new problems, of course, another supportive thing to be having artificial intelligence to be rise and rise more on, or having more orientations in the future, because as the humankind we have new technological components and we reach to new problems. Even COVID-19 is a new problem in terms of medical state. Of course, there are some backgrounds, but the COVID-19, as it can be seen from its name, is a new problem for the AI, for the humankind. And we will be always having new problems in terms of medical, in terms of lifestyles, in terms of building something, or living in the cities, or dealing with the nature itself. So artificial intelligence will be always having open problem site in terms of new problems, so in terms of new fields or different fields. And we will be always open problems, of course, with supportive technologies. Just think about running some supportive technologies to make your system to be more effective, maybe for the target problems. And more rise of the field of AI rises more discussions or issues regarding openness in AI, because for example, Elon Musk thinks that the AI should be open because people should be knowing about if the AI details of AI will be threatening, or actions by AI will be threatening humankind. So he says that the AI should be open, and he has already supported the establishment of a company called as OpenAI, which is running solutions by providing their source codes or other things as open to the worldwide. But for example, Mark Zuckerberg says that the AI is not very dangerous as the humankind thinks like that. So there is the issue of copyright. So the scientific, even scientific world, not only the private sector or technological side, companies side, is divided into two groups, but the scientific world is divided into two groups, which are thinking the copyright issue and the openness issue respectively. And of course, the existential risks and ethical and safety-oriented issues will be very active open problems in the future. Data is exactly the open problem because the future will be built up over the data. As you know, even COVID-19 is tracked and controlled, tried to be controlled and tried to be diagnosed or threatened thanks to data flows, use data by patients, by people actions, blah blah. So data will be always open problem for the future. And there is another interesting research topic, biocomputer based inspired systems, which we can, for example, say like brain-computer interface, efforts in brain-computer interface. And some scientists think that the future of intelligent systems will be somehow combinations of biological and electronical systems, digital systems. So that's another interesting, remarkable open problems combining all medical biology and electronics, maybe other technological fields, and especially computer science, AI, in one common group to think about biocomputer systems of the future. And as the suggestions, I can say that especially to students, to our friends from different degrees, from different classes and fields especially, I can say that not only learn about the algorithmic styles, algorithm solutions, but also learn about philosophy of AI and its essentials, because all of technologies, all of algorithms and techniques are associated with somehow philosophy of AI lying on the background. So some, for example, popular science books or other sources are very effective to learn about them, and not by just reading about the engineering side, but also reading about the theoretical side will be gaining more and more knowledge power to you to learn, to be learning about the field of AI. And also learn algorithmic details, of course, AI techniques, but not write codes always directly by using some ready libraries at the first step. Just try to write codes manually by your own efforts, because Python, for example, has lots of libraries to write, also even just using some four lines of codes to run even diagnosis of cancers by using deep learning. But that's not the exact way to learn about the algorithmic details. If you want to learn more about AI, just try to write manual codes, and after that, of course, you can write whenever you or whatever you want when you are working for a private sector or by just running against a deadline. But if you learn about logic on the background by writing manual codes, you will be gaining more time and being more expert in the field of AI. And also learn about supportive technologies, data science, statistics, to have more about learning more about AI background, and learn about some mathematics and logics. But do not fear about mathematics and logics when you are beginner to do AI, because of course, if you want to be a deeper expert for building up or creating some new algorithmic site or AI safety base, for example, systems, you may already be knowing about mathematics and logics more. But because there are already mathematicians to making that possible or happened or in real time, running in real time, you may not just needing a very deep mathematics or logics at the first step. By just running or learning more about different techniques or artificial intelligence based solutions, you will be already having necessary knowledge about mathematics and logics on the background. So that's another suggestion by me. And choose some subfields to work in. There are machine learning, deep learning, optimization side, as I've said before. Just try to join to events like that nice webinar, for example. Just join to the training programs, online courses. You may already know about MOOCs, massive online learning environments, because in our time we didn't have such opportunities, so you will all have. Read about AI, not from only the scientific sites, publications about AI, but also learn or read about news, blogs, videos, newsletters, because there will be always detailed scientific sites to learn about AI, and also popular sites, popular science sites to learn brief information and direct information about the state of the AI in terms of present or future world, for example. And also you may follow famous scientists like Nick Bostrom, Ray Kurzweil, Stuart Russell, or other men from around worldwide, You may already following Elon Musk, but Elon Musk is not famous scientist exactly. He is now is just a businessman. So in order to learn more about scientific side, you should be following some famous scientists. You should be searching for them, because scientists are generally on the back of the closed doors, not like businessmen. If they are businessmen, of course you can be knowing them, but just follow famous scientists. I don't know if I'm very famous, but you may also follow me, and just follow famous scientists to learn more about the future, more about the open problems, and more about new concepts, or future of AI and future of world, of course. Yes. Thank you very much for listening. I hope my presentation is not very long and boring you, but I hope you already have some important and remarkable information. Your questions are all welcome. In order not to interrupt the communication side, I'm just stopping my share of the desktop. So I will also see the chat environment panel. Yes. Thank you very much, dear professors, and all questions are welcome. Yes. Let's see.
So Professor, I have a question for you, but
Yeah,
before
sure.
we should go with the participants' questions first. Attendees,
Okay,
please
sure.
raise your hand if you have any questions. Just let me know. We do have a chat options, or you can directly raise your hand so we can allow you to ask a question to Professor directly. Kindly raise your hand. We do have first question from, okay, Professor Yogendra Simani, sir. Yes, sir.
Good afternoon, sir, or rather at your place it must be evening, so good evening to you. We teach a lot of subjects to our students which go beyond university requirements. My request to you is if you can help us prioritize that. What would be the most important subject according to you to teach my students so that they can be industry ready? And I'm talking about the final year and the pre-final year students.
About improving their knowledge about AI, you mean, dear professor?
Yeah, that's the field I had in mind.
Yeah. At first, you know that the algorithmic thinking style is very important. So writing programming codes, or writing algorithmic solutions is very essential. So I think you already giving such courses or knowledge to students. And after that, you may be giving some courses or lectures regarding AI by dividing it into two groups, as I explained in my presentation. One of them is the machine learning side. The other side is for example, intelligent optimization maybe. And you may also give some information regarding knowledge-based systems or knowledge representation courses, because we just run some learning algorithms, machine or deep learning algorithms. It's okay. But also we just run some intelligence optimization algorithms. That's again okay. But another thing is to make the target problem, the problem from the real world, to be understandable by the AI, which means preparing your data in terms of knowledge representation and knowledge rules by using knowledge rules, and also modeling your problems in terms of mathematics, which means optimization, or for example, design optimization problem is associated with the mathematical modeling. So courses regarding knowledge representation, mathematical modeling, and also machine learning as a different way, just focusing on the learning systems in itself, will be effective. And also maybe at early steps, early classes, I mean, early levels of the degrees, you may be giving some courses regarding essentials of AI by just explaining some algorithms, like I have done in my presentation. For example, explaining fuzzy logic and maybe genetic algorithms and neural networks, by just saying that these are all under different groups, but you will be already having more information in the future if you want to learn more about separately about each of them, for example. Yeah, that's maybe an effective way. And maybe if your departments or fields are associated with electronics, especially, you may be also having some courses regarding smart technologies, maybe embedded systems, including some developments of intelligent systems by using electronical components, which means embedded systems using some Raspberry or Arduino based systems, I mean, or sensors, actuators, which are giving some insights to especially robotics maybe for the future. And also that's important because the world is now under attack of smart environments, topics of smart environments, and the future will be probably rising over such things, because even our iPhones or smartphones are just IoT devices with lots of sensors located inside them. So if you have some electronic sites also, you may just thinking about smart solutions with hardware support. Some courses regarding them, maybe smart intelligent hardware-based systems, maybe the course may be called like that. Yeah, that's all.
Thank you, Professor.
You are welcome, dear professor. Thank you.
Okay, we have another question from Dr. Pankaj Porwal.
Yes.
Let me...
Good evening, Professor. So my question is about the paradigm that is used to train AI systems currently. It is still mainly data-based. You need very large amount of data to train any kind of AI system, or rather machine learning system and deep learning system. Now, is there any possibility of having deductive kind of learning in AI? Like humans not always need a lot of data to learn something. They can deduce more learning from existing knowledge. So is there any possibility of incorporating that kind of learning or that kind of thing in machine learning or deep learning?
Yes. Thank you, dear
because
professor.
for achieving AGI and the ASI, I think something of this sort will be very important, because
Yes, because the data, the big amount of data, or the mechanism of that artificial intelligence requiring data to learn something to provide a target is a important issue, because the lack of data, or the lack of, for example, missing data is another important problem. Dear Professor Porwal, thanks for your question and good evening. And I can say that there are some research efforts to derive some synthetic data. I can say the synthetic or imputed data. I cannot remember the exact term, but we can say the synthetic, creating synthetic data efforts are rising popularity in especially the last 2 or 3 years. And even I'm working with one of my Master of Science students to make some use of synthetic data. And that requires, I think, less efforts to derive some data which are not exactly gathered or obtained from the real environment, but having necessary or enough statistical, how can I say, correlation of connections to make enough, to be enough for having effective solutions at the end. So that may be probably be providing solutions for future problems which we do not have enough information about their past tastes, for example, or not just regarding that issue, by just not dealing with trying to having some past known data gathering, and by just losing some time to gather data. So synthetic data creation is another important research topic, I think, but there are some dangerous sides, of course, because the synthetic data means human product data, so that means it may include human errors. So running some human errors elimination patterns, techniques, or just trying to some running effective solutions to make such synthetic data to be as successful as or useful as to be having successful results for your target problem. So that's an important research area, I think. So you may just take a look at to that research field, because there are some efforts, but still should be improved in time. So I think that will be solving that data needing problems of intelligence systems. So building up some machine learning systems, maybe reaching to that artificial general intelligence, that the new concept that I have explained in my presentation. Yes.
Okay, thank
Okay.
you.
You are welcome. There is another question to the chat site.
Yeah, we have another question from the Vivek sir. Let me.
Yeah. Okay.
Yeah, Dr. Vivek.
Says that what happens when a program that can write its own code diverges from the intentions of its creator to achieve its goal. Yes, that can be another harmful problem, because that's another discussed problem for the future of AI. But for example, as I explained about the interruptible or interrupted AI systems in terms of AI safety, there are some research efforts to eliminate that problem. It has a very deep mathematical side. For example, you can search over the web by just writing safely interruptible agents. I can remember like that, safely interruptible agents.
Recently, last few years, Facebook encounters the same problem.
Yes, certainly. And the researchers wrote that paper from Oxford, from maybe Stanford, I can remember, from such institutions, taught that or introduced or explained that they have a very deep mathematical techniques to make an agent, an intelligence system, we mean, to be interruptible when it starts to be acting out of control its creator. So there is a big red button in their explanation, in their terms. There is a big red button to be pressed when the program or the intelligence systems tries to write its own code, for example, or just try to make some harmful actions. So dear professor, dear Vidit, you can take a look at that paper, and by just looking at that paper, you will be always reaching to some additional papers. I cannot remember exactly their title, but there are lots of different logical and mathematical research regarding that problem. But it's still open. It seems still open, having some open sides like cybersecurity. Cybersecurity has lots of solutions, lots of the defensive technologies, but it always has lots of counter attacking techniques again. So you reach to the starting point again to derive some again safety oriented or defensive oriented techniques again. Yes.
Okay, now we have another question from Dr. Vivek. Dr. Vivek, you can keep your question short.
Thank you, sir. Sir, which tool in MATLAB to implement ML and AI algorithms with the help of the MATLAB? Which toolbox is supported?
Can you repeat, dear professor? There was
Sir, which toolbox are used to implement ML algorithms or deep learning algorithms in MATLAB?
In MATLAB,
Yes,
you ask about the library or component, ready component?
Ready components.
Yeah. Actually I'm working in TensorFlow and Keras from in the Python side exactly, and wrote some ready codes in my own efforts while writing some research papers in MATLAB side, but I cannot remember exactly some names, but there are some ready written some codes of MATLAB to be running ML of deep learning side in MATLAB. Of course, there are some ready tools inside that, like NN tool or other things you already know about them in MATLAB. But in terms of deep learning, I cannot remember exact names actually, unfortunately. So you should take a look at to the web,
Okay.
actually, dear professor. But for example, for Python, I suggest you for Python, Keras and Keras and TensorFlow,
TensorFlow.
scikit-learn, for example, for Python, scikit-learn is another strong component. And Colab is by Google, and it runs TensorFlow on the background, and you do not be required to be having some GPU or other things, because by using the cloud environment, Colab allows you to use their resources to make your deep learning model to be trained or run, especially. So I can suggest them in terms of Python, unfortunately. But just send me a mail to utkukose@gmail.com, and if I, after the presentation, if I just encounter with some ready libraries or remember about some of them, I can re-inform you again. Okay.
Okay, sir. Thank you. Next question from the Mr. Lalit Yagnik. Lalit,
Yes.
sir, you can ask your question.
Yeah, thanks, Professor. One question in your opinion I'd like to have is that whenever I've also talked about this AGI and ASI and the timelines of 2040 and 60, then
Yes.
I'm always asked that, is it based on opinion of some respected few, or is it really built on, again, prediction using some machine learning based on certain parameters, might be algorithms which are emerging and hardware which is emerging, the social aspects. So what's the, I mean, can you throw some light on and your views on these dates?
Yes, I think I remember. I know that these are all just numbers derived by some, how can I say, futuristics or scientists working on the future of AI. So I remember that there are not exactly some certain calculations to predict the exact years of 2040 or 50, but maybe it's an interesting subject that maybe, I don't know. I have not read such papers or sources from the web, from the scientific audience exactly. But maybe it's an interesting approach to make some components to predict some years, some data, to be having some predictive information about when the AGI will be real or ASI will be real. But the scientist also says that all advancements of new concepts or new types of AI are just somehow how can I say, hidden advancements which are slowly rising and appearing in when they are at the appropriate time to be spread along all fields of the modern life, like for example wearables, or like just smartphones with having some touchable screens, for example. All the rears were passed because of some background works to make them, their costs to be lowered and to be make them real, to be used by everybody. And when we just reach to some years, maybe to 2000s, maybe we just started to be using smartphones with touchable screens. And that's the rise of AGI and ASI, maybe like that. And as you remember from my presentation, there are some, for example, 2040 is used for the rise of AGI. But according to Nick Bostrom, the 2040 is for, especially for ASI. He says that it's 2040 and 2050s, maybe. He says that, so that's maybe another clue about that. All of these are just predictions by scientists working in the future of AI. but that gave me or everybody listening to that webinar interesting idea about running some input data, for example, advancements in terms of electronics, advancements or in terms of data science maybe, and rise of AI systems by just using some time flow, time series in terms of developments starting from maybe 1990s. And by just using them, we may just run some deep learning or machine learning systems to give some predicted dates, maybe, or times, years, dates, months, and times maybe to be knowing that that exact time we will be experiencing the power of the AGI or ASI. Yes.
So you think that we could start some project on that, right? Do the
Yeah.
And we
Yes.
make some assumption that AI will not hit another winter, because I used to work in expert systems back in 80s at IBM. And
Yes.
at that time, we thought that this is going to take over. The AI in the rules-based system will take over, and then comes COVID like a winter. So a winter came along, and the AI went hibernating. So I think making those assumptions, I feel that we may be able to do some work in that direction. So good to see your thoughts. Great, thank you.
Yeah, you are welcome. Yes, you are certainly true, dear professor. Thank you.
Okay, do we have any other further question from attendees? Yogendra?
There seems a question from Rajkumar.
Yeah, we can have a question from Rajkumar. It's saying,
as we know our future as ASI, so what are the studies are going on to counter the ASI system? As I said before about safely interruptible agents, there are such research efforts to be having some interruptible systems which are having some big red button, I mean, and except from that, there are some research works regarding the concept of bias, for example. Bias is another important problem because as like the humankind, if you know more false information about somebody or something by hearing from other sources, you just try to have some bias against him or the target problem, maybe about political things or maybe somebody. So the bias is exactly an issue taking place in even nature of the humankind. So in terms of data, we hopefully at least having the power of manipulating some data in terms of bias. So there are some research works in both attacking side and at defensive side, which means, for example, adversarial attacks are known as placing some pixels over image data or just placing some raw data, affecting the way of the learning capabilities of the target machine learning to be knowing false information about the target problem. So that becomes or brings us to the issue of bias. So in the other defensive side, there are some research efforts to run some effective algorithms which are just figuring out some false information or some not correlated data, which will be probably causing some unbalanced results in longer terms for your intelligence system. So that's another research site, adversarial attacks and defensive solutions for adversarial attacks. Also, there are some, for example, research works on beliefs that may be derived by intelligence systems, which means, for example, when you are going to some target for solving some target problem, for example, when you just start to going to the market to buy some bread or something for your home, you may just see something while going to there. You may just see some friends or some other places, shops, and remember or just think that I should buy that thing too in addition to the things that I will be buying from the market. So you can just change your mind or just manipulate your mind very fast and very unpredicted state. So research works are some research works are also focused on that issue about unpredicted results and useful unpredicted results, which we mean. So in the future, maybe some intelligent systems working for you as personal assistants, maybe just running some unpredicted useful decisions while trying to solving something different. And researchers just trying to provide some algorithms for making that real. I can say that. There are many other research works. Of course, I can say that you can just take a look at to the future of Humanity Institute maybe for more detailed research. Also, OpenAI, the company. Also, Leverhulme, Future of AI Center. I remember incorrectly. When you write Leverhulme, you will be reaching to the true site. And also, there are other centers. Just use the words of research labs and maybe machine ethics and also AI safety keywords over the web. You will be reaching to many research labs from around the world. There is also MIRI Machine Intelligence Research Institute from USA. There are also MIT, CSAIL. You may already be knowing about them. These are all very important research labs and environments. You can have more information about superintelligence or future of artificial intelligence and also safety-oriented things. Yes. Another question. Is there any common framework?
So
yes.
it's question by me. I would like to ask the last question.
Yeah.
Right. So
the
biggest challenge in the adopting artificial intelligence is that there is no common framework or a universally accepted approach that draw the process outline for AI adoptions. Many startups and many companies are using drives innovation and process with just use the AI like leveraging the capabilities of the AI from a need perspective.
Yes.
Mostly they have a problem with the data analytics, or I can say their logistic, and want to use AI to solve. So I would like to ask Professor, is there any a common framework available, or you can suggest that is good to kickstart to process of any AI development and almost all companies can utilize? I mean, it boils down to the basic and can leverage by any company, or I can say early stage student developers that is working with almost every AI development applications.
Yes,
if you can suggest in such a rules, regulation or framework every AI developer should follow to develop such application to protect the user information and privacy as well.
Yes. I remember that there is no any common framework, but out of the framework structure, there is a remarkable rising interest against or to using reinforcement learning, which means learning from experiences. So researchers are just trying to build up some universal reinforcement components to make every different types of machine learning systems to be run for every types of problem. For example, at last step and last time, we just be trying to building some projects against educational self-learning steps or self-learning routine or self-learning strategy development system, and we just try to manipulate that system by not running optimization things or just running some maybe supervised, unsupervised things by just using some reinforcement components. So reinforcement seems to be one of the most remarkable components for the future of AI. but I do not remember exactly a common framework in terms of software system. But it seems to be everybody is using the Python framework, as you know, or for example, we can talk about Julia. Julia is rising and rising more popularity day by
Over
day.
the Python.
It's
Yep.
yeah, it seems to be one of the featured programming languages for the AI, and it's always open that we don't know exactly if somebody or some research institutions are building some ready components in terms of target AI based programming languages. But the problem solution is just making or gaining more wind from the reinforcement side. So reinforcement side opens every discussions, like if the future actions can be predicted by processing steps. So because that's the way of learning from experiences, everybody asks about some set of experiences to make an intelligence system to be running effectively by using only reinforcement system. So that seems to be an important open problem for the future, for the
Because
companies.
nowadays we need to teach students along with AI fundamental that to keep user privacy as well, because we can't use the
Certainly.
entire things. Yeah, exactly. So my major issue when we deal with student projects or student learning about AI and ML, it's to keep their focus on to protect the user data as well. So
Certainly.
so we need to design such a framework in a design thinking way, so we can involve the framework out of for the AI learning perspective and the development perspective for the early stage student developers.
Yes, at this point, for example, I can suggest, especially to students, to listeners, maybe looking at to the blockchain and IOTA data models. As you know, IOTA and blockchain are all different. IOTA, I think, according to me, IOTA has been introduced to the literature at a early time, I think, when we compare it with the blockchain. But the developers or the creators of the IOTA says that it's even powerful or robust against quantum computers. So maybe combinations of AI, ML, and such data models, distributed data models around the world, will be another key problem of the that data privacy, or at least keeping data safe. So maybe the safety will be also another important topic, not for only everything in terms of cyber security, but for also especially AI of the future.
Right.
Yes.
Thank you, Professor. Thank you very much.
You are welcome. Thank you very much, dear Professor, for
Over
your question.
to Yogendra.
So thank you very much, Professor, for such a informative session. I hope all the participants, inclusive of students and other faculty members, have been enlightened by your talk and have gained much more from your talk. So on behalf of Techno NJR family and IEEE student branch Techno NJR, I would like to thank you once again that you have given the time from your busy schedule for this webinar. Thank you so much, sir. Thank you very much.
You are welcome. You are welcome, dear Professor.
Thank you.
Yes.
Yes, Professor, thank you for delivering such a wonderful talk. We'll be in touch.
You are welcome. You are welcome, dear Professor. We will be certainly in touch. Thank you very much for all of you for your kind invitation, and in personally, we will be always in touch, of course.
Sure.
Thank you very much.
Thank you so much, sir.
Thank you very much.
Thank you. Bye bye. See you again.
Bye bye, sir. Bye.
Bye. Thank you.